tietenkin sitä käytetään lokkauksella.
Yes. So now we are ready to continue with what is the causes of decline and something about the Kunming-Montreal Agreement. And I think you have already maybe touched upon that in the planetary boundaries course, but if you will have the main cause of decline, then it's this habitat loss that's causing the decline of 500,000 of the species. So that areas are becoming smaller. You just need a small disturbance of some sort, then the population is gone. So loss of habitat is the absolute main reason. And when we look at habitats, you could say that human actions have altered 70% of the land surface. That's quite a lot. But also 66% of the ocean surfaces are experiencing cumulative impact from human activities and things like ocean acidification. 85% of wetlands has been lost, and 77% of rivers longer than 1,000 kilometers are no longer running freely. In the coastal ecosystems, it's the one that is deteriorating most rapidly. And the seagrass extent is decreasing by more than 10% per decade, and the kelp forests have declined 38% of their biogeographic region originally. And we are, of course, focusing a lot on kelp in our research group with the Agora project and the Green Feedback project. And then the 5 primary drivers for this change. Habitat loss is by far the most important one, but then you have also invasive species like king crab and pink salmon, and which really change the ecosystems. Overexploitation, especially in the marine environment, overharvesting of fish has been a major problem, and then pollution. And you saw the novel entities of the planetary boundaries. Some people think nuclear energy is the solution, but nuclear waste is contributing quite a lot to changing the status of the planet, because you have to store it somewhere. So that's also one problem with that. Plastic, microplastic, you also know probably seen a lot about, and then you have the climate change, which André is talking about. But what you can manage is not maybe exactly the number of people, but the underlying drivers here is more people, increasing consumption, and then we don't use resources efficiently. We waste a lot of resources on the way. Yeah. And this latter point, I must say, when I think about it, 95% of the resources we use in Europe are just being, in a way, becoming waste. And the waste is a resource. So if we could use some of that 95% that we extract from the rest of the world and recycle it to use for something else, then we could reduce the pressure quite substantially. So a big problem globally here is the linear economy, where you extract, especially from non-Western countries, take into Western countries and dump as garbage. We could get that circularity, we don't have to steal so many resources from the rest of the world.
So in other words, you're saying that only 5% of the materials is recycled.
Yeah. Yeah, that's what I say. Yeah. Yeah. So that's something often a missed point. People focus a lot on population growth, but the population growth is going to level off. It's like if you've seen and read Rusling's book, Factfulness, you know, population growth is maybe not the biggest global problem, it's a problem locally somewhere in different parts of the world, but this is not what changed the world the most. It's the waste of resources, it's increasing consumption. IPBES has data on that. I will show you soon. Well, this is a very crazy figure, yeah, I know. But the point here is that you have this influential, which is indirect drivers. There's the values and behaviors, change in population, and sociocultural factors. You have the economical and technological, also solutions here, that institutions and governments and conflict levels. All of these societal factors are influences these 5 key pressures, direct drivers that are affecting biodiversity directly. And as you see here, land or sea use change is the biggest influential here, or affecting biodiversity the most, except for with the marine, you also have overharvesting. And I've gone a lot through some of these and before, so it's ecosystem species extinction risks, but you also have biotic integrity, that is how much of the ecosystem has native or non-native species. That has declined by 23%. Then you have biomass of wild mammals that has fallen, and then you have indigenous and local communities have made their own indicators, which has also been measured in this report, and they are also declining. So underneath it all is something Tamer already spoke about. It's the great acceleration. So I'm not going to go into that in detail, but you could see the industrial revolution here and the great acceleration happening since approximately the 50 years ago, in the 1950s. Then this changed drastically, and you got an exponential change, leading to this hockey stick pattern. And there are many hockey stick patterns here, and they all point in the same direction. How much evidence do we need? More evidence do we need? If you look at those figures, of course you cannot say that this causes it, because everything is changing at the same time. So to do it statistically, it's everything is changing. So you cannot really have like solid scientific evidence like the physics people can. But what you can is really to show this pattern. And you could see here that the hockey stick pattern, these are the indirect drivers, like the human activities changing the state of the world. And this population has increased, gross domestic product, investment, damming rivers, water use, fertilizer use, urban population increases, more people living in the cities, paper use, McDonald's, which is often used for purchase power, that means that people buy more also, motor vehicles, telephones, and tourism. All of that has increased from the same pattern from 1950. And when you look at the state variable here, it's CO2 emissions, yeah, all of this. This you have learned from the planetary boundaries, so I won't go through them. So what has happened next is the blue acceleration. And this did not start in 1950. You could say that when things have started to be exhausted on land, the ocean became the new ocean economic frontier. So many activities and extractive activities has moved to the ocean instead. And that has happened largely by year 2000. And you could see that aquaculture, hydrocarbon extraction, deep sea minerals, desalinization of seawater to get fresh water, use of marine genetic resources. This is really the patents for innovative practices in the ocean. It's shipping, cables, cruise tourism, offshore wind farms, and you also have some positive news. It's a little bit increase in marine protected areas, but not near as enough as the coming Montreal Agreement wants. Yeah, and they have also extended the continental shelf to make the economic use more easy. Yeah. So, and here is the point of this. Why this acceleration comes is because we as individuals get higher footprint also through our consumption. And you could say that the global footprint, that's where you measure how much area would you need with your consumption rate. Yeah. So it's converted into a hectare, how much area you need. And you can see for an American citizen, he would need 9 hectares, while also the Nordic countries are quite high in terms of how much hectare we need to sustain our lifestyle. And there is other countries, China, India, Africa, and the rest of the world, is very small compared. So if we were going to be on average with the rest of the world, only 383 persons could be sustained at Tromsøya with our consumption. With our consumption rate, sorry, there's another calculation I was thinking. With our consumption rate, given that we have a finite planet with finite resources, only 383 persons can be sustained at Tromsøya. Really, we should only have been 383 here if we were not going to use less as the other countries in the world. And here, this one I think is also very interesting, showing the importance of internet. And IPBES has been very clear that international trade is maybe the most important here to focus on for halting biodiversity decline. But what he has used, Svein Settel, he has lived in Norway previously, but is now living in Czech Republic. He calculated the percentage of potential primary production per capita we use from biodiversity hotspots in the world. And here, only the 10 most important ones have been plotted. And you can see here, I put it up because it's very funny, because you could see Norway is actually, through our trade of agricultural products and coffee, from these hotspots here, we are causing a net loss, only Norwegians, a net loss in biodiversity in these hotspots through our trade with South Africa. So this is the reason it's so difficult to do something about is that each country are managing their own biodiversity, but the consumption which we extract from the rest of the world is not accounted for. So the main finding from IPBES is that the problem here is that global population has doubled. That's not as big as problem as consumption, which has increased by 45%, which is not as big as problem as the economic activity, which has increased with 300, so some get more, I would say, as the global trade has increased by 900%, extracting from biodiversity-rich areas. And the extraction of living material from nature has increased by 200%. Yeah. And 900% means that it's not only the last one there, but the reason it differs is that 900% also is like use of land, you know, for all these activities, while extraction is direct products coming from nature. So the conclusion of IPBES is we have to decouple growth, because all countries need growth to distribute to people for welfare. We have to decouple it somehow from material use. If we don't do that, the generation to come will suffer, right, from this. So if we could find a way to increase GDP without using material resources, that's where we need to go. And perhaps also we need to realize that a good quality of life is not necessarily depending on increased consumption of materials. So that's the main arguments of IPBES here. And we need a transformative action. Transformative actions to bend the curve. We need fundamental, system-wide reorganization across technological, economic, and social factors, including paradigms, goals, and values. And that's why we are now working with this. How can we fundamentally